Okay, geometry students, in this video, we will continue to look at surface area of two more solids. Now, please remember, students, we're going to be in this chapter, we're going to be dealing with a lot of surface areas and volumes. So I think it'd be very wise for you to get maybe a list somewhere in your notes, a formula sheet or a formula list where you have volume formulas listed out for different types of solids and surface area formulas listed out for certain types of solids, okay? Because we're going to be doing a lot of surface areas and volumes. Now, we've learned how to find the surface area of some other solids. Today, it's going to be two more solids. And let me fix that real quick. Two more solids. In the last lesson, we studied prisms and cylinders. Today, we will be studying pyramids and cones, okay? So these two solids are what we're going to be looking at today when it comes to surface area. Alright, moving on. Now, your heading for today is surface area of pyramids and cones. Please copy that in your notes. The lesson number is 12.3. And like I say just about every day, I encourage you to put today's date because that will keep your notes organized, okay? So please copy all of this into your notes. Surface area of pyramids and cones. So obviously, how many formulas do you think we'll be looking at today? Two formulas. Let's start off by looking at the picture below, taken from page 600 in your book. Now, the whole reason I do this is so that you don't have to draw the drawing that you're about ready to see. Do you see what I'm saying? Some of you have really good drawing skills. Others of you are like me. You don't. And so in your notes, I would just write page 600, okay? And then put something in your notes like pyramid, regular pyramid, know the terms, something like that, page 600, pyramid, regular pyramid, know the terms, okay? And then make sure you understand these terms. No, they're not going to be fill in the blanks, okay? Not at all. But if I say to you, look at the vertex, or look at the base, or look at a lateral edge, or look at a lateral face, or the height, or the slant height, or, you need to know what these terms mean. So in your notes, I would write down page 600. Pyramid and regular pyramid, know the terms somehow in your notes. Let's talk about this. The first thing I want to show you is the difference between a pyramid and a regular pyramid. So please listen carefully. Now, right there is about the center of your base, right in the middle, okay? But notice how the vertex is not directly above it. If you were to drill a hole right here and stand on top of the pyramid and to drop a rope down so that it dangled 90 degrees and touched the bottom, it would not hit the center. But if you were standing on top of this pyramid, again, wonderful drawing skills, and you were to put a hole here and drop a rope straight down through the center, if it's a regular pyramid, it'll form a 90 degree, it'll be perpendicular to the ground, okay? As long as the pyramid's not built on a hill or something. But this point here will be right above the center of your base, okay? So, do you see the difference between a regular pyramid and a pyramid? A regular pyramid has the center, or the vertex right above the center of the base, and the other pyramids do not. Now, take some good notes. If I'm going too fast, have the supervising teacher pause the video, whatever you need to do. Now, the reason I showed that to you is notice that a regular pyramid does not have a slant height. Now, we've talked about this before, but I'm going to do it again. The height of a pyramid. Now, this pyramid here has a height. It does have a height. It'd be right here from the vertex straight down to where it hits the ground right there. 90 degrees, that would be the height, okay? But a pyramid like this one here, that's not a regular pyramid like this, does not have a slant height, okay? A slant height is, once again, you're standing on top of the pyramid, and I've told you this before, guys, you have a friend down here, and it's like if you take the rope and toss the rope right down the middle of this side, right in the middle, so that this side here is congruent to this side over here, okay? If you were to do that, and then hold the rope while this guy climbed up the pyramid, the length of this rope would be the slant height, okay? you're seeing what the slant height is. Now, once again, if you were drawing, like I've said 100 times, drilling a hole and dropping a rope straight down, right here, perpendicular, that's the height. Okay, now, I've told you guys, I've mentioned this before. Have you listened? I've told you what lateral surface area is. If you have a cylinder, I told you the lateral surface area would be the surface area of the side, not the top, not counting the bases. Same thing with a rectangular prism. We learned this last week. If you have a rectangular prism like this, and I said, look at find the lateral surface area, that would be the surface area of the sides, not counting the top or the bottom. Okay, so when we talk, so it's so obvious, guys. When I say look at the lateral, the lateral faces, that's any face that's not a base or a top face. You know, a base or a top or the bottom face. Okay, let me say it again. I kind of stuttered there. A lateral face is any face that is not a top or bottom face. So the lateral faces would be this side here, this front side, this left side, this back triangle over here, but it would not be this bottom base here. That is not a lateral face. Same thing over here. A lateral face would be any of these sides, this triangle, the left side, the back side, etc. Okay, and I'm not going to use some of these terms like lateral edges, base edge. Those are common sense, because a lateral edge would be an edge that connects two lateral sides. That makes sense, or two lateral faces. A base edge would be the edge of a base. That makes sense, okay? Of course, the vertex is the very top point of the pyramid. The base is whatever it sits on. You can have a triangular base, a rectangular base, a square base for a pyramid. All of those are possible, okay? So the base is what it's setting on. So understand this. I'm going to move on. And most of these terms, guys, are so self-explanatory, okay? But I wanted to look at those. Now, here's the formula that I'm going to give you now that will enable you to find the surface area of a what? Not just a pyramid, but a regular pyramid, okay? So, remember, this is not a regular pyramid, okay? So this formula I'm going to give you enables you to find the surface area of a regular pyramid, okay? So here we go. Alright, here's the formula. So go ahead and copy this in your notes. In just a second, I will tell you what each variable stands for, okay? So go ahead and copy this in your notes. Capital S equals capital B plus 1/2 capital P. And then this is a L right here, guys. This is a little L. The book's going to write it like this, like that, a cursive L. This is a lowercase l. Now, what do these variables stand for? Well, I'm glad you asked. Please copy that. Well, if you know what they stand for, that's fine. But if you don't, make note of this. Capital S stands for the surface area. Capital B stands for the area of the base. Capital P stands for the perimeter base. L stands for the slant height. That's a new one, I believe. Slant height, okay? Alright, so there's our formula. Now, with that in mind, this really shouldn't be too difficult, okay? Now, if you are given a pyramid that is not regular, and I ask you to find the surface area, then what you would have to do is find the surface area of each face, and then add these areas together. Okay, let's go back a couple pages here. If I ask you to find the surface area of this pyramid here, notice it's not a regular pyramid. So you have to find the area of all four lateral faces. The front, the left, the back, and the right. Find the area of those four sides, and then find the area of the base and add all five sides together, okay? But having said that, look at this next comment. However, most, if not all, of the pyramids we're going to be dealing with in this lesson, in this chapter, will be regular pyramids, okay? So 99, if not 100% of the time, this formula will be just fine, okay? Alright, so with that in mind, let's give it a shot. Now again, I try to help you not draw things in your notes, okay? For some of you that are drawing challenged like I am, so in your notes I would simply write page 601, example 1, and let's find the surface area of these two pyramids. Let's start off with this one right here first, okay? The surface area right here. So, here we go. This is a right pyramid, by the way. We can make that assumption. How can I make that assumption? Well, there's a slant height right here. Is there not? And I told you, a non-regular pyramid is not going to have a So as soon as I see that I have a slant height, I know that I have a regular pyramid. So let's see what our formula is. Formula to find the surface of a regular pyramid is S equals B plus 1/2 PL. Now, let's see what we need. We know that we're looking for the surface area, so I'll bring down my S. We know the area of the base, right? The base is a square. It's a square, okay? So 5 times 5 is 25. Of course, 1/2 is 1/2. The perimeter of the base, capital P, well, 5, 5, 5, and 5. You have 4 sides of 5, so 5 times 4 is 20. And the slant height is given to you, which is 5. Now, I would like to pull up and park here for a second, and I hope that you'll listen to me. Pretend for a second, if you would, please, students, that I didn't give you the slant height. Pretend that I gave you the regular height like this. Okay, what are you going to do? How are you going to find the slant height? Well, I'm going to show you going off to the side. What you would do is you would draw a line over right to the middle here, and then draw the slant height. Got it? And notice you would have a right triangle. Okay, so let's pretend this height right here. Now, you're not really probably taking notes on this, just watch. Let me back up again so make sure no one's confused. What would you do if I didn't give you the slant height, okay? Pretend that you did not know that the slant height was 5, like it is right here. They told us the slant height is 5. What if we didn't know the slant height? Pretend this line right here, this red dotted line, is not there, alright? Well, what you would do to find the slant height is you would have to draw the height and come straight over to here. Now, remember, this whole side here is 5. So from here over to here would be 2.5. It would have to be half of the 5. Now, you would have to know the height, okay? Let me go ahead and draw the slant height here. You would have to know the height, and let's pretend it's 4, okay? So then using Pythagorean's theorem, you can find the slant height. We'll do something like that later or in your homework, okay? But understand, in this case, they give us the slant height, so it's pretty easy, okay? So what I have is this. If you take your calculator and multiply 1/2 times 10 times 5, or 1/2 times 20 times 5, you will get 50. Now, if you add those two together, you will get 75. Remember, we're dealing with a surface area, and area is always square measurements. So 75 square feet. All right. Now, I think I made one mistake. Yes, I did. I just caught it in the book, and I apologize, guys. Very sorry. The slant height is 4. I'm not sure how I could mess that up. It's right here in front of me, but I do apologize. So this would be 40. 1/2 times 20 times 4 is 40, and this would be 65. So grab your erasers. You know, when you have Mr. Earhart teaching you, there'll be plenty of mistakes. So fix your notes real quick. Make that a 4, make that a 40, make that a 65, and let's continue on. Now, we're going to find the surface area of another pyramid, okay? And here's the pyramid right here. Now, it is a regular pyramid. I know that because, first of all, I can tell the vertexes. Really, though, in geometry, you're not supposed to make assumptions, but it looks like the vertex is pretty much over the middle for the most part. But since I've taught you not to make assumptions, let's not make assumptions. Let's draw this thing here. Okay? And notice that's a slant height, and I've told you you cannot have a slant height unless you have a regular pyramid. So I know I have a regular pyramid because I have a slant height. So I know I can use this formula here. Now it looks like a pretty easy one again, guys, I think. Alright, so let's take a look at this and see. First of all, let's see what the area of the base would be. Now this is going to be interesting, but at least, okay, now I need you to really focus and really concentrate and think outside the box. If I want to find the area of the base, over here the base was a what? It was a square. Was it not? Sure it was. Well, over here it's a 1, 2, 3, 4, 5, 6-sided regular polygon. So we've learned if you have a 6-sided regular polygon, like that, pretend you're up in the air looking down on the surface, it would look like this. Well, you guys know how to find the area of a regular polygon. Come on, what's the formula for finding the area of a regular polygon? Because look, guys, you got to find the area of the base, do you not? That's what the formula says. And your base is a six-sided regular polygon, or in other words, a regular hexagon. How do you find the area of a regular hexagon? Well, it's going to be 1/2 times the apothem times the perimeter okay? So we know what the perimeter is. All of these sides are 6, so the perimeter is going to be 36. That's pretty easy, all right? But the apothem right here, we got to find it. Well, they gave it to us. Look right here, it's real hard to see. Look, see this dotted line coming right here to this right here? Sure you do. Well, that's 3 square root of 3. So I know the apothem right here is 3 square root of 3. So 1/2 3 square root of 3. So now if I grab my calculator, which of course I don't have with me, let me look in the book and see if they have that done, okay? What they did is they took 1/2 times 3 times 36, and they got 54, which is fine. So what they have for the area of the base is, are you ready? 54 square root of 3. Now if you have a decimal right here, instead of 54 square root of 3, I have no problem with that whatsoever. In fact, that's what I would probably do if I had a calculator with me right now. But I do not, so 1/2 times 3 square root of 3 times 36. You would take outside number times outside number times outside number. This 3 right here is an inside number. It's under the radical, so we're not going to multiply with outside numbers. So 1/2 times this 3 right here times 36 gives you 54 times square root of 3 plus 1/2. Now, the perimeter of the base is going to be, well, all the way around here. So it's going to be 36. Okay? 36. And the slant height, they give it to us right here, look. The slant height is 8. Alright? Now, I don't like how this looks, a little sloppy. So let's get, hopefully we're okay with finding the area of this regular hexagon. There we go. So your slant height would be 8. So with a calculator now, you would have 54 square root of 3 plus 144. I believe I did that in my head, but I think that's I think that's correct. I hope that it is. So 144. Now, if you then with your calculator type in 54 square root of 3 plus 144, you will get this answer right here. The surface area equals 237 meters squared. Okay, guys, if you got to back it up again and watch it, back it up again, okay? It's really important you understand this. Surface area of a regular pyramid. Now, let's continue on. Moving on to cones. Let's take a look now at the picture below. You can find this in your notes on page 601, students. So go ahead and write in your notes, picture on page 601. That would be a smart thing to do, all right? And there it is. So I would encourage you to write in your notes, page 601, know the terms of a cone, and then go ahead and turn your books to page 601, or you can follow along here. Now, this is called a right cone because the vertex, once again, is directly above the center, okay? And so we form a right angle here. We call this a right cone. Makes sense, doesn't it? Here's your base. The base of a cone is always going to be a circle. That won't change. Remember now, guys, once again, my good old famous drawings. If you're standing on top of this, pick this object, and you drill a hole right here and drop a rope straight down, that's called your height. However, if your friend is standing over here and you drop a rope down to him on the side and they grab it and climb up, the length of that rope right there to the edge of the cone would be the slant height. The slant height. Again, this, okay? Slant heights go this way, heights go vertically, perpendicular to the base, straight up and down. Now, the lateral surface, of course, once again, lateral surfaces are any face. That's not a top face or a bottom face. So it's pretty simple. We know that. Now, once again, if you ever have to find the slant height or the regular height, if you know two of these, pretend this is 8 and pretend this is 5. 5, you can find the slant height because you have a right triangle right here. Right there, you have a right triangle. So using Pythagorean's theorem, you can find the slant height. Okay. All right. So moving on. Those are the terms you need to know when it comes to cones. So in your notes, make sure you've written down page 601. And when I say know the terms, I'm not talking about fill in the blanks. I'm talking about knowing how to be given instructions using certain terms, and you know what the terms refer to on a cone or on a pyramid. It's your job to know those. Like pyramids, most, if not all of the cones that we'll be dealing with will be right cones, okay? And the formula I'm about to give you is only for right cones. Just like the formula I gave you way back here, it was only for a regular pyramid, okay? Alright, so here's the formula for finding the surface area of a right cone. Here it is. Copy that down, please. And if you need to, if you're not sure what R stands for, which of course is radius, or L, slant height, then please don't be embarrassed. Copy this down so you know, okay? So I'm going to pause for a second. Please make note of this. And then here's all the information about each variable. Capital S is the surface area, R is the radius, and L is the slant height. Please take a second and copy that down. Well, this is it, students. We're done. So take some really good notes. Here we go. Find the surface area of the cone below. Are you seeing how this chapter is going to be a lot of formulas? And by the way, I'm 99.9% sure on the test of this chapter, I'm going to give you the formulas on the test, but I'm not going to tell you what they go to. I'm just going to list out, like, I wouldn't put S equals. I would just, guys, the mouse, the pen, my pen is low on batteries. I have some batteries here. I'll just use my mouse here. I'll just give you this. And you'll have to know what that's still a big help though, okay? So, I will give the formulas in that form on tests and quizzes. That'll help a little bit. Alright, here we go. Let's find the surface area of this cone right here. Let's find the surface area. And so, here we go. The formula's right here, so I'm going to write it again. S equals pi r squared plus pi r l. Well, for pi, obviously, I'm going to put 3.14. For the radius, I'm telling you the diameter is 5. So from here to here, all the way across is 5. So half of that would be 2.5. So the radius is 2.5. And then, of course, squared, because we have a squared right here, plus 3.14 times the radius, 2.5 times the slant height. Now, here we go. We're finally getting into one where I don't give you the slant height, okay? So we're going to have to find the slant height. So I know the height is 9. Now the height is the length coming from here to the center that forms a right angle. So the slant height would be this measurement right here. Well, look what I got, guys. I'm going to highlight it in a different color. I've got a blue right triangle right here. And I know this distance from here to here is 2.5, and I know the distance from here down is 9 because they gave that to us right here. So all I have to do is use Pythagorean's theorem, and then I can find this slant height right here. So here we go, students. Let's first of all square the 2.5. So 2.5 squared. I've got a calculator now. Let's see, we get 6.25. So I have 3.14 times 6.25 plus 3.14 times 2.5. Now, let's go ahead and do our multiplication right here. And if we do that correctly, we're going to get 19.625. And then over here, if I do my multiplication correctly, I'm going to get 7.85. Now if we add these two numbers together, I'm getting, and hopefully I've not made any mistakes, 27.475 units. There was no measurement given as in terms of feet, inches, or centimeters. No label for the measurement, so units squared. And there we go. That's the surface area of this cone. Okay? Alright. So guys, I hope that you're learning this material as we go through this chapter studying volumes and surface area. I hope this video has been a help to you. If you have any questions, never hesitate to call or email.